Yeah, this is the example. This is a matrix. I'd like to find the inverse of. Again, the beginning is the same. This is when we augment with the identity. When we augment with the identity, again, I will hide some steps which convert this matrix to the row echelon form. I will hide some steps which convert this matrix to the row echelon form. These are the steps we know how to come up with. If you, I mean, I hope you know if you listen to the Monday lecture. Now I will take it to the reduced row echelon form, the one which has the perfect identity on the left-hand side, but I will avoid any scaling at all. I will be doing fractions instead. It will be a little bit hard in terms of crunching numbers, but you have calculators anyway, so it's not that hard. And that will save me time and space. So look what I do. I'm not going to cancel this -1. I'm going to keep it the way it is. And so my first transition will be just aiming to vanish this -2. This is the row operation which will achieve that. First row transformed into first row taken 2 of the third rows. That will vanish this -2. This is the result of this. Again, what happens on the right-hand side, I don't address right now. You can double-check it in your own time. Now, my next step will be using this -3 to vanish this -3. This is a row operation which will achieve that effect. I will take my first row and subtract the second row. And the effect is achieved. I've got the 0 in that place. And this is it. See? This is now a perfect diagonal matrix. All I have to do now, I have to do cancellations. I have to do cancellations, and I will do them in one step. All of them in one go. Look at this. I'm going to take away minus from the row 3. I'm going to take away -3 from the row 2. I'm going to take away another third, or another 3, I should say, from row 1. In one go, I can do it because this operation, they do not intersect. They do not intervene with one another. And the result will be my perfect identity matrix on the left-hand side. See how many steps I saved? A lot. And in fact, in this example, we didn't even see those difficulties I promised you because we didn't deal with the fractions. There are other examples which I'm not discussing in class, but which I will publish on Moodle. In those examples, you will have fractions. And here's my inverse. It's a lot shorter method. You see how less space it takes, how less operations we need to do, how less matrices we need to copy from step to step.